Hello, you're welcome to this video. In this video, we are going to be playing around with some stuffs, we call them approximate numbers, all those numbers that the values, especially those last values of your measurements, okay? So now we want to just do a little few things like the algebra of approximate number, or you can say computation or calculation with approximate numbers. All right, so that's what we are going to be doing in this video. Multiplication or division, addition or subtraction of approximate numbers. How do we undo them when it comes to multiplication, division, and all that? Okay, so now, before we go further or deeper into this, I'm going to bring something to your notice, like I want you to recall that I told you in some previous video that the last digits is usually that digit that carries the error. Is that digit that has the approximate figure. You understand it now? So most of if anything is approximated or anything is rounded off, that thing, what is usually affected or what usually carries the mark of approximation is the last digit. All right. So if I have a number like maybe 2.152, and I have another one like 2.1, and I have another number like maybe 1.45. Okay, so considering these three numbers here, we believe that if any approximations has been done, the approximation must have affected only one number, which is what? The last number. So any rounding off or any rough estimate that you do, okay, and then you conclude at a particular point and you write it out, that number, that thing is always the last, the thing affected is always the last number, okay, when you approximate. Okay, if for instance now, I want to round this up to the nearest whole number, or I want to round it up to one decimal place, you know, I will say 5 will go down, and we add 1 to this one, so it becomes 1.5, right? You see that this value, this last value, is the rounded off value, is the approximate value. Do you understand what I'm trying to say? So that's why we said it is always the last number. This 1.45 now is probably a number that is longer than that. That was now rounded off, okay? And then we stopped at one point. The place we stop is still the last number, okay? So the last number is usually the what? The approximate number. Take note of that. All right? And then also take note of something. When you say significant digits, okay, we are not really only specifying zeros. Look at this number here. It has 3 significant digits, right? 1, 2, 3. Because the rule says that every non-zero digit is significant. Remember that rule, right? So if you look at this, 2 significant digits, this is 1, 2, 3, 4 significant digits. All right? But if I have 0.025, it has 2 significant digits, which is only 2 and 5. Why? Because the zeros that come before a significant digit is not significant. But if I say 5.1200, please, my brother and my sisters, this number has 5 significant digits. You know why? 512, they are normal numbers, so they are significant. But zeros after the significant figures are also significant, based on what we did in the previous video. Do you understand that? So this one now has 5 significant digits. This one has 2 significant digits because the zeros that came before is non-significant. But zeros that comes after the number is significant. Okay? So this one has 5. This one has only 2 significant digits. And then all non-zero numbers are significant. Do you understand that? So that's as per that. Just important for you to take note of that. Okay, now let's go back to this discussion. Okay? Now we have 2.152. If we want to add this number, let's say we want to add up the 3 numbers, we want to add them up, okay? We, let's say, these approximate values, anything they come across to, they will be infected. So, this is 152, this is 1, this is 45, so this one just goes straight down as what? As 2. It has the bar on top of it, okay? All right, so this is normal 5, but this is a 5 that has bar. I put bar on top of the approximate numbers, okay? Those last numbers, because they are usually the error number or the rounded off number. You get what I'm trying to say? So now 5 plus error 5 or plus approximate 5, it will give you 10, right? 0 does, you put a bar on it, remainder 1. 1 adds to this one, okay? 1 plus 1 is 2. Normal 2 plus bar 1 will give you bar 3. You get what I'm trying to say? So the moment any number comes across the one carrying the bar, it will automatically carry bar. You get that now? So it's like the bar is like an infection. So even though you add a 4 without a bar, you add this to 1 with a bar, then the result will be a 5 with a bar. The bar infects it. Do you understand it now? So the bar is infectious. Just have that, look at it, that picture it that way. So we have, this one was like 5 plus 5, 10, 0 remainder 1. Okay, so the 1 adds up to this one. That makes it 1 plus 1 is 2. 2 plus bar 1 is bar 3. And then bar 3 plus normal 4 will give you what? Bar 7 points. Okay, 2 to 1, that's 5. So you have 5. If you notice very well that the final answer has 3 approximate, like 3 error number, or I don't know the name to call it, call it approximate numbers, okay? So they have 3 of it. So there is a rule in physics that makes us to understand that when we have approximate number, or when we have numbers with error, possible errors, number with errors, we should always try as much as possible to stop at to reduce the error to only one. Only one error number must be represented. Only one bar number should be represented. The remaining ones will be rounded off. So if I want to write the final answer for this addition, I am going to say my final answer, my final result is what? 5.7. Okay? Keep only one of it. Drop the rest off. That is, round the rest off. Only one of the approximate value should be written. The rest should be dropped off. So whenever you are representing, so assuming during the process of the addition, this 7 did not carry bar, but this 0 carries bar, and this 2 carries bar. Okay, the 7 that did not carry bar, you leave it, you write it. The 0 that carries bar, you leave it too. But every other one that carry bar beyond it, you will drop it off. So which means if my final answer was something like 5.702, and only this last 2 carry bar, all right, if that has been the case, if that was the case, okay, I'm going to represent my final answer as 5.70. Okay, so this one, I will stop at the nearest one that carry bar and then drop off the remaining one. Okay, so we try as much as possible to reduce our error in our results by making sure that only one of it remains, only one of it is represented. You get what I'm trying to say? So that's as per that place. And then, if you know, so having said and done that, if you take notes, you will see that our final result happens to be to have a number of significant digits as the least precise measurement. Hi. All right, okay, let's see. Let me show you something. This measurement is precise, This one is more precise. And this is the most precise. Why? The precision, this one gives more, this one gives detail, this one gives more detail. Why this one gives most detail? The more the number of decimal places, the more the precision of that measurement. We believe that measurement that is close, that the value is tiny, that can depict tinier values, have what? More precision. Do you get what I'm trying to say? So that is what we see here, okay? So out of the 3 numbers, which one is the most precise? The most precise measurement among the 3 is, the least precise measurement among the 3 is this 2.1, okay? And then it happens to have the same number of significant digits as the final result. And this is what always happens every time. This is what always happens every time. So, and that is what bettered this law. This law says that, it says, while adding or subtracting approximate numbers, round off the sum or difference to the units of measure as the least precise measurements. So which means that while adding or subtracting all of these approximate numbers, okay, it says, whether it's addition or subtraction, the same law applies, okay? So it's just trying to tell you that you should round off the sum, that is the total, everything, okay, to the units of measure as the least precise measurement. The least precise measurement has a unit of measure of 0.1. So our final answer too must have a unit of measure of what? 0.1. Do you get it now? The least precise measurement here has 2 significant digits. Our final answer, okay, that one works for multiplication because they look alike, but they are different. This one deals with the precision, while this one deals with what? With significant digits. So we are coming to that. When we get there, you will see. Do you get it now? But when it comes to addition and subtraction, it is more specific about what? About the unit of measure. All right? So your final answer, the one that is specific about significant digits is the one for multiplication and division. But for the addition and subtraction, it's more specific about what? The unit of measure of the least precise measurement. So if the least precise measurement has maybe 0.01, your final answer too must have the unit of measure of 0.01. You get what I'm trying to say? So, but ideally, without the law, ideally, it is just a practice that you round off your result to make sure that it has only one approximate value inside it. Okay? These approximate value, we use the bar to represent them. You drop the last two off and then you keep on. So let's play with another number just for verification purpose. Another set of numbers. Okay? Oh, I should have used that one to explain this labor saving rule, but okay, no problem. Maybe we'll do it with this one. So let's say we have 1.32, 1.435, 1.21111. All right. So, as you have it this way, the last one. So let's do our addition. Okay? Well, let me just not constrain. Let me just do it this way. Okay, so we have this. Okay, 1 like this, 5 plus 1, even though this one is not carrying bar. So the one that has bar, we infect it. So we have bar 6. And then we have 2, 3, that's 5, 6. Okay, having bar. Then we have 3, 4, 5. We have 3 plus 4 plus 2. 4 plus 2 is 6, 6 plus 3 is 9. So we have 3 points, all these things. So at the end of the day, you see that the 9 is not carrying a bar, right? So it's safe. But out of all the ones carrying bar, we drop the other ones off. We round up the answer to the last one that is carrying the bar. So we have 3.9, and then the last one carrying the bar, so this one will be like 7, okay? So which means we round up the answer to have 3.9 to become 3.97, okay? So you drop off the other ones carrying bar, keep only one of them, that is the very first one. Then round off the results to that first one, and then you stop there. And so that is why we have the final result as 3.97. And if you look at the final result, you will see, what is the precision? The precision of the final result is what? 0.01, okay? Based on the fact that we try to keep only one of the approximate values and then we dump the rest, okay? So it has the precision of 0.01, okay? Like, let's say 2 decimal place. Then you will see that the least precise measurement here too has 2 decimal place. So it always happens like that. The number of decimal places that the least precise measurement has is also usually the number we round off our answer to. Okay, we round it up our final answer to have the same number of digits, the same precision, which is the number of decimal places as that of the least precise measurement. Do you understand it now? So that's that. Now, but then that reminds me of this labor saving rule. The labor saving rule is just trying to say that, okay, before adding or subtracting, round off the numbers so that they contain one more digit of precision than the number of precision of this English. Let me show you practically so you get what the English is just trying to say. Now, it's just trying to give us a shortcut of adding numbers or subtracting numbers, like the shortcut of adding them. when we have approximate values, or when we have when we have numbers with this decimal place and all that. So if you want to add them and still get the same result, and then you don't want to start doing all these things, okay, you first approximate. Now what you do is that you check the least precise measurement. The least precise measurement is having what? It's having 2 decimal places, right? Good. So you will now do the precision, you will now round off, like let me now assume that I want to add this guy to this guy first, okay? What I'm just going to do is that to add this one to this one first, I will round off this one to have one more digit, or one more significant digit than the highest one that's the least precise measurement has. That's what this guy is just trying to say. Before adding or subtraction, round off the numbers so that they can contain one more digit of precision than the number of precision digits in the least precise. This is the least precise measurement. The number of precision digits we have there is what? Is 2. So you are going to make sure that you round off the other ones to also have what? 2, before you now go ahead to add them to each other. So I have an intention of adding this one to this one. So I'm going to make sure that I drop it to 3. You know this is 2, so one more for it will be 3. So which means I'm going to be saying, this one is already 3 now, 1.435, already 3, right? Then this one is how many now? This one is 1, this one is 4. It's having 4 precision digits. That is 4 decimal place. So I'm going to round it up to have 3. Because the lowest one we have is 2. So you round it off to have 1 more than the lowest one. So 1 more than the lowest one will be 3 digits, 3 digits of precision. So we have 1.211. So you first add these 2. Adding these 2, we have 6, 4. This is 6.2. Now, after you are done adding this one, you now finally add it to the last one. So when you want to do the last one too, you check it out. The last one does not have up to 3. So you leave it that way, okay? Because we want it to be 1 more than the least precise. So you now add. So when you do your final addition, you have 6 here, 4 plus 2. 4 plus 2 is also 6. And then we have 6 plus 3, 9. And then we have 3. So this 3.966. So the 3.966 now, at the end of the day, you round it up so that it's going to have the same number of what do you call it? Unit of measure, okay, or number of decimal places as the smallest one. So at the end of the day, the answer is 3.97. Do you get it now? So this labor saving rule is just like a rule that cuts off excesses. That anything that is excess, you cut it off first before you do your addition or your subtraction. But in the process of cutting the excesses, you make sure that you cut it down only to 1 more digit beyond the lowest, the one with the lowest number of decimal places. That is the one with the lowest precision. Do you get it now? So when you want to cut this one now, you cut it because the one with the lowest precision has only 2 digits here after the decimal point. So therefore, because it has 2 digits after the decimal point, this one has 3, this one has 4 after the decimal point. The one that has the smallest number of digits after the decimal point is the least precise. Okay, so you drop every other number here, you approximate it first to have 1 more digit beyond the precision digit of the least precise. The least precise here is 1.32. The precision digit is 2 digits, right? So which means if you want to round up every other one, you round them up to become 3 digits, 1 more than it. That's why it says that before adding or subtracting, round off the numbers so that they can contain 1 more digit of precision than the number of precision digits in the least precise. You can understand that English now. Is it making sense now? So the number of precision digits in the least precise measurement is 2 because this one is here. Then if you want to round off to 3 decimal places before you add or subtract. That's what this law is just trying to say. We call it labor saving rule because it will prevent you from having to add plenty other one. So because if this one is like 2.111135789, you know, I will first have to add all this one, add all this one, add all these ones. Then before I reach here, then I will now drop everything. So to save that work, to save that labor, to save that effort, we now said, okay, fine. Look into the things you want to add or subtract. Okay? Drop off every other number and stop only at what? One more significant digit. Okay? Beyond the one more precise digit or precision digit beyond the one of the least precise. When you do that, then you can now proceed with your addition. So it cuts off a lot of excesses before the addition or subtraction will take place. You understand it now? So that's for this. So I'm done with these parts. The addition, the subtraction rule, and the labor saving rule that works for addition and subtraction. I'm done with it. Okay? Now, we move on to the one of multiplication and division. So I think I would have to clean up this. And then please go to your course material, the topic that is talking about computation of approximate number, go there. Check the examples they wrote there and play around with those examples. Okay, I'm using a different example here. So use those ones to practice and check your answer with theirs. Okay, just for you to practice with. Please do the same to every other topic that has been treated so far. All right, so I can rub off these parts. You may rewind the video and pause it if you want to write down the rule, but I'm sure the rule will come out in your exam. One of those filling the gap questions. Okay. All right, so we want to deal with the second one, which is the product or the quotient rule. Okay, quotient means division, product means multiplication. So we want to deal with this one now. All right, so to deal with this one, what do we do here? Let's assume that we are multiplying. We want to multiply maybe three numbers, 2.1 times 1.35, okay? 2.1 multiplied by 1.35. Let's just even start with a smaller example first. Then we can now extend it later. All right, so if I need to multiply this, knowing fully well that, yes, the approximate number is usually the last digit, right? Okay, fine. Now, let's do the multiplication. If you want to multiply, you say 1.35 times 2.1. You see, when you are doing multiplication, you will first ignore this decimal point. You do it as if you are multiplying 135 by 21. That's the way you do it. Just ignore the decimal point first. Do your multiplication. So when you do your multiplication, now 1 times 5 is 5, 1 times 3 is 3, 1 times 1 is 1, 2 times 5 is what? 2 times 5 is 10, 0, 1, 2 times 3 is 6, plus 1, 7, 2 times 1 is 2. So, you add up, right? So we have 5, 3, 8, and 2. Okay? Now, you count the number of decimal points place that you have. Here you have 1 decimal place, here you have 2. So making 3, Abby. So you now shift it 1, 2, 3. So which means your final answer will be what? 2.835. That is how to multiply numbers that have decimal. Okay? Do normal multiplication. When you get your answer, you count the number of decimal places, the total number of decimal places you have, then use it to bring this guy in, and that's all. From the right into the number. So the final answer is 2.835. Okay? But now during the multiplication, infection happens. The last digit here, the last digit here, right? When one, like this one, Abby, and this one. So 1 times 5, we have this, 1 times 5 is 5. 1 times 3, we have this, and then we have this. At the end of the day, during the addition, okay, because this one has a bar, the result of it we have bar. Bar 1 times bar 5, we have bar 5. Bar 1 times normal 3, we'll have bar 3. This bar, the moment it comes across anything, it will infect that, and that thing will carry bar. So this 1 times this one too, we have the bar. Okay? Now, 2 times bar 5 will be what? Bar 10. Remaining 1. Ordinary 2 times ordinary 3. That's 6 plus that 1, 7. Every other thing is now ordinary. 2 times 1 is 2. And everything is fine. Okay? But the one that carries bar, whenever it multiplies anything, that thing too must carry bar. It's infectious. Either for addition or subtraction, or for multiplication or division, is infectious. Okay? So, now, because this one carry bar, when we add this to 0, is bar 5. Bar, you have what? Bar 3. Bar and no bar, you know, send. Bar 8. Okay? The only guy that is safe here without bar is 2. So at the end of the day, you have the answer as what? 2.835, 3 bars. And you know what the rule says. The rule says that when you have something like this, it's only one of them that you keep. You keep to you reduce the error by sticking to only one of the error value or approximate value. So you stick to, so final answer by applying the rule is what? 2.8. Okay? So that is the final answer for this. And then if you look at it very well, you will see that the final answer we got has the same number of significant digits as the least precise factor. Do you need to take notes? This is a factor, this is a factor, and the two of them are multiplying each other. Okay? The significant digits here, how many significant digits do you have? 2. How many significant digits do you have here? 3. So you see that the final answer we eventually got by applying the rule of the bar, whatever, is having the same number of significant digits as the number with the least significant digits. That is what this law is talking about, the product or the quotient rule. It says that's what? It says the product or quotient of 2 measurements should be rounded off to contain as many significant digits as the measurement having fewer number of significant digits. So if you look at these 2 measurements now, this one is the one that is having the least number of significant digits, right? So when you do your final answer too must have the same number of the significant digits as the number with the smallest amount of significant digits in the measurement that you multiply. Do you understand? So for clarity, let's play with another example. So if we have 2.1 times 1.35 multiplied by 0.05 multiplied by 0.05. Check this out. So to multiply this, well, we will first need to do the first 2. Then the first 2 now use to multiply the last one, right? So that it will be easy for us. So the result we got from the first 2 was when this one multiplies this one, we are going to get 2.835, right? Okay. So 2.835, you now bring this one in by saying 0.05, right? Now, if you are talking about the infection, remember that this one has infection. Okay? For 0.05, the last digits too, we have an infection, right? So we multiply it by 0.005. Okay? And remember that this one has infection. Okay? So if we do that now, do the multiplication, you will see 5 times 5 is 25, right? 25. We are going to do the multiplication as if nothing happens, as if no decimal point is there. Then later you now put the decimal point back. So I want to shift to the front because I don't want this number to be disturbed. Or since you've already known the answer, so I can erase it. Okay, so let me see. This is 2.8 approximately. Now, so let's do 5 times 5 is 25. 5 remainder 2. 5 times 3, 15 plus 2, 17. Okay, remainder 1. 5 times 8, 40. Plus 1. Plus 1, 41. Remainder 4. Right? Then 5 times 2 is 10 plus 4. That's 14. So you have 0 times everything here. You know, 0, 0, 0, 0. 0 times everything here too. 0, 0, 0, 0. So at the end of the day, you have 5, you have 7, you have 1. Remember that the one that has infection, okay? 5 infection multiplied by 5 infection will give you 5 infection. 5, everything that this infected 5 multiplies will carry infection. Do you understand? So 0, 2 multiplies 5, okay? It carries infection with 5, infection with 3, infection with this. But 0 multiplied by this will not carry any infection. You get it now? So I think the next 0, 2, we have 3 infection. The fourth one will not have. All right, so now let's see. 5 infected, 7 infected. We have infection. Infected 1 is 0. Infected 4 infected. All right, 1 infected. And then we have what? 0. No infection. At the end of the day, this is our final answer. Okay, we need to know the number of decimal place. 1, 2, 3, 4, 5. So 1, 2, 3, 4, and 5. So our final answer is looking like 0.141175. Okay, with all of these guys carry infection. And as the law implies, you drop off the other one, keep only one. So the final answer is what? 0.1. You see that? Assuming this one is a number that can approximate, you approximate it, but it's not. So you leave it as what? Is 0.1. Now, but this is because we apply the law that the one that has infection should be dropped off and then keep only one that is not having infection. So that is why we have our answer as 0.1. Now, if you merge this answer, you apply this law to this, you will see that you get the same answer. So this law is there so that we will not need to be looking at the one that has infection or not. This law is created so that we will not have to be looking out for infection or no infection, so that it will just take us to the answer without having to consider infection or no infection. You get what I'm trying to say? Because what this law is saying and what the answer of infection dropping off is saying, they are the same thing. They both always arrive at the same result. In fact, this is what bettered this. So in order to just make sure that, okay, we are working more accurately and speedily, then this law was created. But these results or the kind of thing that we arrive at in each case here is what bettered this law. So now the law says that the product or the multiplication of two measurements should be rounded off to contain as many significant digits as the measurement having the fewer number of significant digits. Now, if you look at this thing very well, this one has 2 significant digits, 2 SD, right? This one has 3 SD, 3 SD. How many SD does this one have? Remember that the zeros that come before a number is not significant, right? So this one has how many SD? It has 1 SD. So that is why by the time you multiply the 3 of them, the final answer you get must be rounded off to contain only 1 SD. And that is why we have our answer as 0.1. So whether we apply the infection law, I call it infection law because the one carrying by infection you get. So whether it is the infection law you apply or you apply this law, you arrive at the same conclusion, which is what? 0.1. But remember, this is the thing that bettered this law. But this law helps us to work faster. So we just know that, okay, fine, whenever I want to multiply, stop looking out for infection, just multiply everything and make sure that the final answer you get has only 1 significant digit, because the lowest number of significant digits among the 3 is 1 significant digit. So your answer 2 must be what? Must have 1 significant digit, period. It makes your work to be faster. You get what I'm trying to say? So that's it, sharp. The same thing too applied for the one of the addition and subtraction too. Follow the law, you get your answer, sharp, and you are good. You get it now? So that is the answer for that. Now, this labor saving rule is just trying to save us a lot of stress. Look at all the stress that we have to go through before we arrive at the answer. So the labor saving rule tries to help you to manage the stress, like, no, guy, don't disturb yourself too much. Just cut off the excesses and then only multiply the shorties, and then you arrive at your answer. You get it now? The labor saving rule is saying that before multiplying or dividing, it says round off the numbers to 1 more significant digit than the number of significant digits in the least precise factor. The least precise factor among all the 3, the one that the precision is the smallest, is this. And how many significant digits does he have? 2, right? So now it says before multiplying or dividing, round off the number to 1 more, the numbers that you want to multiply, round them off to have one more significant digit than the number of significant digits in the least precise factor. So this is a factor. We know when two things are multiplying each other, you call them factors. When they are dividing, you call them quotients. Okay? So, factors. So the result of two numbers dividing each other is what we call the quotients. Okay? The quotient of two integers and all that. So, but then let's just come back to this. We have the one that has the least precise, the factor that has the least precision now is 2.1. How many significant digits does it have? It has how many? 2. Good. So, which means that you will let the other ones to have one more of it. That will become 3. Then you now multiply. Just that these numbers that I'm working with now, they are shorter number. But assuming I'm working with numbers that has more decimal place, then this law, you will understand it. You will be able to apply it better. But here now, they are short numbers. Although the law will still apply, the law still applies. Okay, let me just use it. Then you can now use the knowledge to solve the one in the course material. Okay. So I'm going to follow the law word by word, word for word, so you can be able to understand what the law is just talking about. All right. So the power saving rule for multiplication and division is what we want to apply now. It says before multiplying or dividing, round off the numbers to one more significant digit than the number of significant digits in the least precise factor. The least precise factor upon all these three now, the one that has the smallest precision is this. How many significant digits does it have? 2. So which means that we should round off all these ones to contain 3 significant digits before we multiply. So 1.35 already contains 3 significant digits. 0.05 contains only 1. So we now say 0.05 contains only 1 significant digit, right? So we increase it to 3. 1, 2. You get? Then we now do our multiplication. So if we're working with other kind of numbers, we may not have this kind of scenario. But then let us just establish it here. Okay? So when we multiply, let's just do the normal multiplication of 135 and 5. So 5 times 3, 5 times 5 is 25, 5 and 2, 5 times 3, 15, 16, 17, 5 times 1, 5. So we have 575 here. So how many number of decimal places do we have? 0, 1, we have 4 here, 5, 6, we have 6. So the final result is going to be 1, 2, 3, 4, 5, 6. So we have this, that is 0.000575. Okay? Then we now multiply this one by 2.1. Now, how many significant digits does this one have? 3 significant digits already, right? This one is just normal 2.1. So if you say 2.1, so let's put this one to 3 significant digits. That's be 2.10, right? So you now multiply the 2 of them. So it is going to be like 575 multiplied by 2.1, because 0 multiplied by all of them too will still give 0, 0, and you still have to add and all of that. So 2.1. All right. So then or 21. So we have 1 times 5, 5, 1 times 7, 7, 1 times 5, 5, 2 times 5, 10, 2 times 7, 14, plus 1, 15, 5, 2 times 5, 10. And then we have this, we have 5, 7, we have 10, 1, 1. So we have that. And then after all of these things, how many do we have here? 1, 2, 3, 4, 5, 6. And then we have 7, 8. So let's see. I think I've used the. See. Yeah, let's use a calculator to save time, because I am running out of time here. So let's just use the calculator to do. What we would have had is 1.35. So we are doing 1.35 multiplied by 0.05, but make this one to have 2 significant digits, although calculator will still give you the same results. Okay, so we have 0.05 multiplied by 1.35. So we have 0.0675. All right, 3 significant digits, just the answer we got earlier. Then now you multiply it by 2.1. So multiply by 2.1, but if you want to do it, to make this 2.1 to have this, you put 0, but when it comes to multiplication, it doesn't matter. Okay, so you multiply it, the result you got, multiply by 2.1, and then you have the final answer as 0.14175. 0.1, just the same answer we got here. And then you can now round it off and then get your final answer. Okay, so it's still the same thing. And then the final answer should have the number of significant digits as the other one. So it just still applies, and then you still get the same result at the end of the day. So that is just it. That's just that for that. This level saving rule is just to cut off excesses during your multiplication. But now you know you'll be using calculator, so you don't have to really stress yourself. But be aware of the rule. So any question that is being set on it, you'll be able to just answer it. Like it can be presented to you in form of a statement, and then put the statement through, and then you get your answer. You fill it in the gap, and then you get your answer. All right. So that is the end of this this unit. If you have questions, please. If you have questions or you have observation, you have anything, please feel very free to communicate with me. All right. So the phone numbers have been flashed on the screen at one time or the other during the video. So you just put it there, put a call through, or send a message through our email or through WhatsApp. We'll do everything, and then further explanation can be given, and then we can relate. All right then. Till the next video. Bye.